I like my shirt. Alright, so we wanna talk about some small stuff today. So one thing is that we have this first, like we have a row of general item which are called products, and then below the first row we have items themselves, this presentation, and then we want to say how should we present these items in order to maximize purchase or clicks. And can we have like fairness if it is like it's a broad query. Another simpler question we talked about yesterday is that how many categories should we show? All right. Let's start with this one, which is quite simple. And another question. So, for example, let's say we have. This is what actually Hassan was talking about too. Makes sense. It's interesting. So we have, for example, Nike, and we have like shoes and socks, and 80% of the, and then we can say, all right, there are two categories, shoes and socks. But what if like 80% of the clicks are for shoes, and inside shoes we have, I don't know, Air Jordan and another running shoes, all right? So should we put them like okay. All right. So you have it. All right. Like, let's assume we have a query like queries Nike. And then we can say, all right, Nike can be shoes, and it can be socks. Alright, I don't want to keep it all about food. Shoes and like t-shirt. And then you may say, all right, 20% of our clicks, 20% clicks, and 80% of the clicks are shoes. And within shoes we have, for example, Air Jordan, and we have um, running shoes, whatever. Is it Air Jordan or Air Force? Both of them, right? Yes, Air Jordan. So what is the other one? The white sneakers? Air. Anyways, I don't remember. Air Force. Alright. So, Air Jordan and Air Force, for example. Jordan and Force. Alright. We have these two. Which are each one is like 40%, 40%. So which presentation is better? Is it this better or this better? This is better. When we search Nike, we say actually. So when should we start categorizing each category? Should I do this? Like should I add layer, or should I say alright, queries Nike, and then I say it is either t-shirt or is it Jordan, and then for Jordan you can say it has different colors, it has different well, this is the question we have, to be honest. Maybe you can say, alright, Jordan also is the kind of like, I don't know, red and blue, or I don't know, based on the model, based on the year or whatever. How should we choose this tree? Right? Like this is like 20%, 20%. What should we say, guys? If it is about information, how much information are we doing? Right? How much information are we giving? This presentation and this presentation. Right? So that is 40, 40, 20, and this is 40, sorry. 20, 40, 40. So one thing is that obviously too wide, like the breadths, if it is like, now can we break it in 1,000? That is not good. Too wide is not good. One. too wide is not good. Too deep is not good. I think there are a lot of things about search on trees, and we can look at them. All right, so let's go to ChatGPT maybe actually. So we need to put a cost for breads. Which will be eyeballing. Or fuck that, B. So let's say cost is the number of layers plus number of breads every time we see. Or like expected number. Categories. So in here, like C1 here is like, for example, 20% get 3 plus 40% times 2 plus 40%, like based on the order, times 1 will be how 60, 80, 140, 140 and 40, 180, 1.8. Here the cost will be 1.8. Here the cost will be okay, that's more interesting now. 20% times 2 plus 40%, right? 40% are going 2 layers, and or we can say 1 plus 2 is the position, plus 40% 1 plus 1, right? So it will be 40, 120 will be 160, 160 and 80 will be 240, 2.4. So this cost is more. That's actually a good cost function. I like it. That's actually very good. So it seems like this tree, by the way, is convertible kind of to this tree. I don't know if you can make this tree to this tree though. This is kind of strange. Like Maybe these 40 and 40, yes, here are like Jordan and but this 40 and this 20 cannot be in the same category. So we can go upwards, but we can, let's say we cannot go downward. So we have a tree. All right, let's say that's the situation. We have a query and we have a tree. And then each one of them has like a subtree. Should we pull it up? That's what I want to say. Can we pull it up and to the, that's what we want to say. So we say, we have a list, let's say like we have this 1 to n. Bag 1, category 1. Or yeah, set, fuck it. So we are something like this. That's bag 1, bag 2, bag 3, and each bag has like this subcategory. Which is like, I don't know, G1, G2, G3, G4, G11, G121, 3, fuck. G2, G23. And then we want to say, what is the cost of this presentation? The cost of this presentation is C1 is G11 times 2, right, plus G12 1 plus 2, G13 1 plus 3, then we have G21 1 plus 1. Each G is also like the percentage of the users, plus G22 1 plus 2, G23 1 plus 3, plus G31 1 plus actually, yeah, G21 is 2 plus 1. better actually, matches with the indexes. So G3 plus 1 plus G3 2 3 plus 2 G3 3 plus 3, right? And C2 is, for example, what is C2? For C2 I have this. So I'm gonna pull back all the B1 items, right? So I have G1 1. Now it's a separate bag. G1 2, G1 3, and then I have B2, which is G2 1, G2 2, G2 3, and then we have B3, which is G3 1, G3 2, G3 3, and the cost of C2 is so G1 1, this time just 1 plus G1 2 times 2 plus G1 3 times 3 plus G2 1, this time will be added by, instead of being 2, it will be number 4, right? So it's just adding 2 to each item. Now they are again in not the same layer, so 4 plus 1 plus G2 2, 4 plus 2 plus G 2 3, 4 plus 3, right? Plus G3 1. This will be number 5. 5 plus 1. G 3 2 will be 5 plus 2 plus G3 3, 5 plus 3, right? And if you wanna, so what are the costs that added in this new red one is that, what are the costs that decreased is the layer cost for the bag one. Yes, that one item, the layer cost of that decreased, but what increased is eyeballing cost, or yes, eyeballing cost for items in bag 2. So that's the trade-off. C2 minus C1 will be 2 times G2 1 plus G2 2. Like for this users, for this portion of the users, we are adding to the cost. 2 3 plus G3 1 plus G3 2 plus G3 3 minus the cost that we lose, which is layer cost for the bag 1, G1 1 plus G1 2 plus G1 3. So if bag 1's population, right, this population is less than twice the sum of this population, right, um, if this bag size is less than twice the size of the rest, pulling this branch of tree upward will add to the cost. So we can only pull it back if C2 is less than C1, which means, for example, 40, it was 40, 40, 20, right? No, we cannot, because some of this, like 60%. If it was, for example, 80% and 10, 10, we could do that. Because 2 times 10 will be, so this is actually, what is this one, by the way? This is just, this whole thing is 1 minus G11 plus G12 plus G13. So we are saying 2 should be less than 3 G11, G12, G13, right? That's what we are saying. So only if the bag 1 is greater than 2/3 of the population, we can do this. What about cost of item? What if we want to pull back item bag 2? Can we pull back item 2? I don't know if it is called pullback, but I want to name it B1 expansion. So now let's do B2 expansion. So it stays the same, B1 stays the same. Okay. Now if you call this cost C2, can I say what is C2 minus C1 on? So C2 minus C1. This part and this part goes away. They just cancel each other out. This part, it is G21, G22, G23. We have just 1 plus 1 plus 2, 1 plus 2. Sorry, how did I say that? Exactly, 2 plus 1. All right, 2 plus 1 Now it is, well, it is item 2, but it is 2 plus 1, 2 plus 2, 2 plus 3 actually. Not in the same sense, it's like number 2. This is number 2. Here, number 2 plus 1. Alright. Here is just number 2. This is number 2 plus 2. Right? 2 plus 2. What about a cost of the layer itself? I'm not saying any cost for the layer. This is the eyeball cost. Okay. First of all, I'm not adding any cost in the layer for this. Yeah, this one misses that. Alright, so first part was wrong. C1 I said here is C2 is 20% times 2. One plus one. Yeah, I think one is missing. Actually, it is 1 plus 1 plus 1. It should be more, even more. Very interesting question. Actually, I like this. It will be 40 times 2.8. It's already 2.8. 3.2. Wow, this is 3.2. So it says we should better pull it up every time. So C1 is this, C2 is C1 is this, sorry, plus 1 is missing. Plus 1. What about 2? So C2 minus C1 will be 2 times, exactly, 2 times this motherfuckers minus, now they have one layer, we lost one layer here, so we can say 2 times this, so it will be 4. So if it is less than, greater than half of the population, it is worse to break it down. Whenever it is greater than half of the population, you can break it down. What about this one? This one is actually an interesting case. Probably we don't need as much to put it down. All right, we haven't entered revenue yet. Maybe you have a very small part of the whole, what is it called? Log document or items that we want to put at the top because they generate more revenue. Right now we are just going for users click, no revenue involved. So that's another layer we can add. So C2 minus C1 will be, all right, I want to write C1 and C2 again. So C1 will be G1 1 plus 1 plus 1 plus G1 2 1 plus 2 plus 1 G1 3 1 plus 3 plus 1 plus G2 1 2 plus 1 plus 1 G2 2 2 plus 2 plus 1 G2 3 2 plus 3 plus 1 plus G3 1 3 plus 1 plus 1 G3 3 sorry 3 2 3 plus 2 plus 1 and G3 3 3 plus 3 plus 1, and then we have C2, which is, right, I have to go to the restroom sometime. Let me go to the restroom. So, good news from the restroom. I think we can only focus on the first branch, because the second branch, we can check it now, but probably second branch is just, all the costs from the first branch will just go away, like if we look at this situation, right? So the cost for the first branch in C1 and C2 will be the same, so they cancel each other out. And it can be, we can just assume that we are limiting our focus to bag 2 downward, right? So cost of C2 is like G1 1, again this term, actually it will be this term, using technology a bit. So, and cost that changes here is this one. G21 now will be G21, which is now is 2 plus, well, we lose there is no, here we had 1 because it was in the second layer in the first position. We lose 1 1, and we also lose 1 for layer. That's it, just 2 plus 0. And G 2 2 will be 2 plus 1, which is number 3, and that's it. In the past it was 2 plus this was 2 plus 2 plus 1, 1 for layer, 2 for its position. Now we have, like, compared to the past, we lost 2. Here again we lost 2, right? Plus G2 3 will be 2 plus 2, which will be again minus 2, like 2 plus 3 plus 1. Now we have, it's number 4, true, and it's 6, so minus 2. 1 for layer is removed, and 1 for pulling up, because 1 is already there. So we lost 2 here, but we now added, in the past we had G3 1 3 plus 1 plus 1. Now we have, so there is also a shift in eyeballing just for the backtick. It's actually simple too. So instead of being 2 plus 1 plus 1, will be 2 plus 1, like, what is the number now? It will be 1 2 3 4 5 5. So it's added 2, right? It will be, what is it? 3 1. It will be 3 plus 2. It will be 5, fucking 5. You just added 2. That's it. 5. Plus 1 for the layer, plus G 3 2, it will be number 5 again, plus 2 plus 1 for the layer, plus G 3 3 5 plus 3 plus 1 for the layer. So now C2 minus C1 is, so first row cancels with first row. Second row we have 2 plus 0, 2 is minus 2, minus 2, minus 2, minus 2, G2 1, G2 2, G2 3, and plus 2 times G3 1, 3 2, G3 3, so C2 1 is less than 0, so we want to pull it back when G3 1 plus G3 2 plus G3 3 is less than. Actually, B3 is less than B1, B2, sorry. And for the previous one was B1 by less than 1. So whenever size of the first bag is greater than 1. This is also the same, right? So if you have like BK greater than the size of the remaining bags, BN plus BK plus 1, you will have this. It sounds like that. Well, I had some simplification. We can generalize it now. Let's assume each bag have different size. I want to make sure that these two here is not just random, and because these two can be like this related to the size of the bag. Sounds like that. Simple, huh? There's an email here I want to see. I don't want to show you that. Alright, we are learning. So we have one bag, B1, 2, and then we have 3, and we have G1, 1, 2, G1, N1, and Ni is size of bag I, and we have G1, 2, G2, 1. To G2, N2, and then we have like, I don't know, fucking K to BK, GK1, GK, NK, and alright, whatever. So let's go B1 expansion. Or pullback or whatever. I'm creating words, terms. So C1 is, what is it? Sigma J goes 1 to M for each bag. I goes 1 to NJ, G, J, I, J plus I plus 1. That's the term, right? And C2 will be so first one will be G11. We are opening B1, right? And we're gonna say and we're assuming this nested structure. I need to wash my head. Alright, and I will need to wash it with shampoo. I do wash my hair. So this time it will be G11 times 1, G12 times 2, G1N1 times N1 plus G2 1. What is G21 will be? G21 will be, it is, what is its number? N1 plus 1 plus, right? Is N1 plus 1 plus the number of the, when we go inside the layer, 1 plus the layer 1, and this will be plus G2 N2, all of them will be N1 plus 1. So this N1 plus 1 term, actually it used to be in this one is G21, 2 plus 1 plus 1. Now it is N1 plus 1 plus 1 plus 1. So 2 turned to N1 plus 1. Now it should be, actually, yeah, I think it's better to write it similar in a sigma. Simplifies better. So it sounds like instead of, it used to be 2, now it is N1 plus whatever. N1 minus 1 is added. I guess it is N1 minus 1 added or whatever. Plus J equals 2 to M. I equals 1 to NJ. What is it? G JI. Now it is, what is it? If you are JI, so we have N1 plus I plus there is an effect of J. Oh, I see. What about this guy? If it is 2, 1, it is N1 plus I plus plus J minus 1, I say. J minus 1 plus the layer cost. True. So if you are in the set 3, you need to have G31. What is it? N1. We have 2. Back 2 is N1 plus 1. And you have B3, which is 1 also. Is that true? And then plus your I. Yes, of course, you need to have plus your I, but J minus 1 is... And the layer cost for sure. So for example, G21 should be N1 plus 1, N1 plus 1. It should be G21 should be N1 plus 1 plus 1 plus 1. G22 should be N1 plus 1, N1 plus 2. Yes, N1 plus 2 plus, N1 plus 1, excuse me, plus 2 plus 1, and for example, GK1 should be times, so N1 plus K minus 1 of them, right? N1 plus K minus 1 of them plus 1 plus I, plus the layer 1. N1 plus I plus J minus 1, exactly, plus J minus 1 plus I plus 1. That's it, true. And then the cost will be C2 minus C1 will be so for G11 times 3, G12 times 4, G1N1, so it will be minus 2 G11 plus G1N1. And what about the rest? Plus for the rest will be J equal to 2 to M, I equal 1 to NJ, N1, I plus J plus 1 goes away, N1 minus 1, and times what? You can see the breadth of each branch matters. N1 minus 1 times G Ji. So it is actually equal to N1 minus 1 G N1 minus 1 what? Tell me. N1 minus 1. The rest of the summation is the GJJ is actually BM plus B2, which is actually 1 minus 2, 1 for the layer, 2 B1, which is N1 minus 1, 1 minus B1, minus 2B1. You wanna C2 be less. If you wanna pull it back, so N1 minus 1 should be less than N1 plus 1B1. So b1 should be greater than n1 minus 1, n1 plus 1, which n1 is the size of b1 actually, the number of the breadth of b1. Let's check if it is true for our previous case, that we have 3 will be 2 over 4. Perfect. And that's nice. And what if you wanna do it for group K, BK expansion, BK expansion, it will be similar. I say that's this formula, BK minus 1 over BK. Is this minus 1? I guess it is the same. I don't think 1 changes here. BK plus 1 should be less than BK over BK plus 2BM. That's the formula, I guess. Let's check if it is true. Let's check if it is true. So I need this photo here. We have C1, which is this term. And then we are C2 will be prior to K, up to K minus 1, it stays the same. After K will be, well, at K will be, what is it going to be? It will be GK1. N1 plus NK, right? Minus 1 plus 1 plus GK2, for example, N1. Actually, yeah, NK minus 1 plus 2 GK NK NK. Then we have Oh shit, no, actually that's not true. K minus 1 plus 1. We just expanded the box K, not any other thing. And for J's after that, we have plus J, K plus 1. I guess we can make it K2. Alright, 2M, I, 1, N, J. What is it going to be? Will be G, J, I, G, J, I, what? Your order will be K minus 1 plus NK plus J minus K. Exactly. And plus then inside it we will go for I, and then we go for one layer. So it is, I can make it K also, J minus I, exactly. And right, I can remove this part. How are you? Okay. And so C2 minus C1 will be K plus I plus 1 and K minus 1. And this is also K, sorry. For J1 to K minus 1 will be the same, alright. Oh wait, we removed so many terms now. Yeah, that's K plus 1. Yeah, we did it wrong. K plus 1. Wait, what? Yeah, I said K minus 1. So K, alright, let's see. Will be before before K they are the same. J equals K to M I equals 1 to NJ. We have GJ by no, we cannot say for k minus 1. No, that's not true. So let's make it k plus 1. What happens for the back k? For the back k, we will have gk1 k minus 1 plus 1, because it doesn't have the layer effect, exactly, plus gk nk k minus 1 plus nk. That's it. It doesn't have I plus 1, nk plus 1. It only has j minus 1. Yeah, actually it doesn't. J minus 1 plus I. What about the layer? I think this one also is wrong. So it is GKI I plus k minus 1. Is that true? I plus k minus 1. Here is k minus 1. Yes. And for them will be k minus 1 plus nk. What did I write it? So for them will be k minus 1 plus nk plus j minus k. Which will be j minus 1. Plus I. Exactly. Yeah. So that's it. We cannot merge k plus 1 and k. Alright, okay, sounds good. Now the terms will be I hope it doesn't fuck it up. Now the term will be c2 minus c1 will be up to k minus 1, they go away. For oh, I see. Alright, for group K, we will have I 1 to nk, gki I plus k minus 1 minus k minus I minus 1. So we lose 1 for the layer, right? It's always like that. We lose 1 for the layer and 1 for also when we go layering. So we lose always 2 like this here, starting from 1 again. And plus j is k plus 1 to m, I equals 1 to nj. 1 to nj gji, what is it called, gji, I plus j plus 1 and k minus 1. So it is nk minus 1 bk plus 1 to bn and minus 2 bk, right? Minus 2 bk should be less than 0, nk minus 1 say what is our proposition. So pk, I see, and this is what is this one. Bk over bk to bm, 2 of these greater than nk minus 1 minus bk over bk plus bm, which will be nk minus 1 plus 2. Why plus 2? Alright, so by the way, why is it nk minus 1? It should be nk minus nk. Oh, it is nk minus 1. Alright, it's not nk minus 1. Okay. Now makes sense. Alright, this one should be less than 0, so we can say nk minus 1 bk plus 1 bn m minus 2 b minus 2 what? bk 0 or nk minus 1 1 minus bk so bk bm. Not plus 1, it is just this is just bk. This is true. This is bk. Greater than is it the same thing I said? Exactly. True. I always know. So one other thing I want to know is that when should we stop? When should we stop categorization? Or nk should be 1. Okay. It's always. I mean, okay, nk equal 1 is always means that it is just the category by itself, right? So that didn't make sense. So one thing I like about this process is that it is memoryless. It doesn't matter how the branches above the branch we are considering matter. It's all about below, as long as it is above this ratio. And as the number of so one thing I like is that one, it is memoryless. It is always about branches underneath. Right? The other thing is that increasing nk does not help. That's also a good observation. I will tell you why. So let's assume now we have a layered approach, right? We have this one, and this one is we have two, and each one is also, for example, 3 layers, right? This is layer K, and this is K plus 1 back, and then each one of them also can grow to something bigger, like 2. This is like 3. All right, what if you decide to pull back one of these, huh? Pulling back a sublayer, what does it do? Increases nk increases, so nk prime tilde over -1 over nk the plus 1 will be greater than nk minus 1 over nk plus 1, right? So if you pull back, if you expand one of those sublayers, we will raise this threshold. So if right now it makes sense, okay, if right now it doesn't make sense to pull back, right? If right now it doesn't make sense to pull back, pulling back a sublayer doesn't help it at all. Am I true? Yes. Will increase the cost. So if pulling back already doesn't help, it means that number 2 means if pulling back does not help, pulling back a sublayer inside that layer does not change anything, because it's a C2 is greater than C1. When you pull back a sublayer, it just increases the threshold, and the cost will increase. So we should not pull back. We are in the situation we should not pull back. Nk minus 1 over nk plus 1 is greater than the ratio. Pulling back a sublayer within them just increases, and the inequality does not change. Alright, perfect. Why don't you see this? Dude, come on, what's happening? We are not connected. Oh shit, I thought I'm... Doesn't matter. Okay. So pulling back doesn't help. Anyways. Let's talk about this. The other thing is that we can say So it's also, in a sense, memoryless in the um, layer sense as well. Within the list and inside layer, which memoryless. Alright, and then what else I want to say? Alright, what are the next steps we can talk? Parameter, variable, eyeballing cost. Just makes it complicated. For example, fn, which is an increasing function of n, and then layer cost, we can say L, and just adds L instead of 1, and I don't think it creates a huge different thing. These are minor things, and the other thing is just adding revenue instead of click. Alright, but I just want to see if there is. Alright, by now we have good stuff already, so I don't want to take it further. This one. Let me share it with ChatGPT and see what they say. Maybe there is already a theory about it. I mean, it sounds simple. Doesn't have share option. Page 11. Can I just print it and even share it? Save as a file. Doesn't have share option. Let's see what ChatGPT does. What? Oh, so you're dumb. Can you? Oh, that sucks, dude. Alright, I'm gonna open it and that's what you did. It's so strange. Why don't we have it already? Oh no, sneaky. Can you polish? Exactly. So, hierarchical categorization, trade offs between shallow and deep trees, and cost evaluation for query structure. The cleaned up and structured version with visual diagrams and polished text with the original. Okay, these are the first example. So, yes, specific but cognitively overwhelming if we deep, go deep. Across formula. DIJ steps of that category. Well, we don't have that. Uh, that's nice. Layer? I thought layer is. How do you like? Oh my god, I didn't know how to write layer. Dude, layer. Yeah, I was right. Why do you write layer like that? You don't have layer like that. What the fuck? Okay. So can you give a polished version of the problem based on the um, notation I used? G J I is the portion of user and BJ. Okay. Size of BJ is the width prime J. Um, we don't have depth. What is U then? Well, that's so wrong. They just got it wrong. So okay, it seems it's not really good. Well, it is J. So yeah. I know. Okay, it is the more fucking general case that we can have LJ instead of J, and we don't have one actually. Alright, alright. Alright. J equal 1 to m. Yeah, as long as it is writing it for me, I don't have any complaint, to be honest. I don't want to. No. J minus 1? Why J minus? Okay. 0 minus 1 plus nk. Alright, one minor thing that I noticed is that what if we expand, but subcategories now should change order as well with bigger categories that we had from the past. Maybe we cannot keep all of them next to each other. Then it will be very complicated. So we should have an assumption that G size of B, size of it, B1 greater than B2 greater than Bn M, and then within for each J, Gj I greater than Gj and I plus 1. Also, G, J, and J, this is very simplifying. G, J, and J is greater than, for example, B, J plus 1. That's how I think. Just make sure you... Um, Wow, why is it so complicated? Give me simple graph. Generating image sucks. Oh shit, what are you doing? That's so wrong. That's not what I wanted. Hierarchy menu design. Alright, just we can look at one of them. Uh, this is it. Alright, we will look at them. Perfect, guys. See you soon.